Well, hi everybody. We're your team. Welcome to Girl Geeks. The whole reason we exist is to champion women in technology in Toronto and showcase some of the amazing women who are in this space. In fact, we don't do any topics, we don't cover any topics where we can't find all women to speak. So that's kind of part of our MO. So thanks for being here and helping us, advance our cause of championing women in technology. So, of course, don't let the name fool you. We welcome all geeks in our midst, not just girls, but we do put a special emphasis on women and championing their talents. So you can find us here at our events a few times a year. You can find us on our website. And tonight, we want you to participate in this conversation and take pictures and tweet out brilliant things you hear on Twitter or on Instagram, our new Instagram page. I'm using hashtag GGTO or GirlGeeksTO. And thank you so much to BrainStation. They are very generous with their time, and they do a lot to support the advancement of women in technology as well. So we have Danny here who's just going to say a quick few words. We can't really do it without them, so thanks, BrainStation.
Hello, everyone. Good evening. Welcome to our South Campus. Some people don't get to see this space, so you guys are lucky. I'm just going to give you a little spiel about what BrainStation's about. We're a digital educator. We like to empower people with digital skills, whether that be in design, development, digital marketing, or management and analytics. So we offer a variety of classes within all those streams. We also do different thought leadership pieces within that landscape. For example, tonight we've got a Future of Marketing panel happening across the street as well. We run introductory events and weekend workshops. And as a thank you for coming into the space, we've left these little blue cards across all of your chairs. We'd like to offer you a free event on us. All you have to do is email me and make the subject line say free event. And if you don't have one, I'll leave some more by the door so you guys can find some. But welcome to our space. Have fun at this great Girl Geeks Toronto event, and hope to see you guys in our space again soon.
Thanks, Danny. And we can also tweet out that information if anyone's interested. We're a pretty full room, so also if you could just squish into the center of the aisles and let other people come in and have some space. But yeah. Pretty sold out event tonight, so thanks for coming. So we have a really great panel for you. I think that's why everyone's here. So I'll introduce everybody, starting with our moderator. Our moderator tonight is Hessie Jones, who is the CMO of Humans for AI, who is our partner on this event. Thanks to them, we're making this happen. She's also the co-founder of Salsa AI. So she'll be our moderator this evening. You'll hear from her in a second. Our first panelist tonight is Maher. She's an autonomy engineering manager at Uber, Advanced Technologies Group. Inmar leads a team of research and software engineers at Uber ATG in Toronto, working on self-driving technologies, where her mission is to bring cutting-edge, deep learning-based solutions from the Toronto research team into Uber's self-driving fleet. Inmar led machine learning and research engineering teams in various Toronto-based companies like Kobo and Kindred, and worked as a research scientist at places like Intel and Microsoft Research. And prior to that, she completed her PhD at the U of T, specializing in machine learning. She's a regular speaker in big data, analytics, and machine learning events, and is very interested in doing outreach activities for young women, encouraging them to choose technical career paths. So our second panelist today is Anna Goldenberg, who is a member of the Vector Institute. She's an assistant prof at the U of T in the Department of Computer Science. She's also a scientist at the Genetics and Genome Biology Lab at SickKids Research Institute. So as a key scientist in this lab, Anna's research focuses on high-throughput experiments that facilitate data collection. And in her lab, she works on creating machine learning methods that make such data useful for clinical diagnosis. And her goal is to use machine learning to decipher human disease heterogeneity. I actually had to practice saying that word multiple times. Anna earned both her PhD in computational and statistical learning and her master's in knowledge discovery and data mining at Carnegie Mellon University. Our last panelist, but certainly not least, is Karen Bennett, who's the VP of Engineering at Selfdriving AI. Karen is an extremely experienced senior engineering leader with more than 25 years in the software development business in both open and closed source solutions. She's also currently focused on AI and machine learning at a new startup, Selfdriving AI. And she's worked as a senior engineering leader at some of the biggest names in tech, including IBM, Yahoo, Trapeze, as well as two startups, Cygnus and Red Hat, which have grown into very successful businesses. So a pretty amazing group of women here. So I'll just call up Hessie, our moderator, to say a few words about Humans for AI, their goals, and just set the scene for our discussion tonight.
Hi, everyone. How are you doing? Thank you for coming to our panel, AI and Ethics. What do we want our society to be? And I want to actually thank Anna, as well as Jess and Amy of Girl Geeks, for allowing us to partner together to bring this topic to you. I hope you come away learning a little bit about AI tonight, but also start to question the things that you're doing from a digital footprint perspective in enabling a lot of these AI capabilities. Okay, so before we get started on the panel, I want to tell you a little bit about me, and then I'm going to introduce what we do for Humans for AI. This is the Toronto chapter, which we're just in the midst of launching right now. So I've been in digital for about 17 years. I've been in the workforce for 25. My grounding is in database marketing, and so I love data. I would say my defining moment came in 2005 when we launched Yahoo Answers in Canada. And for me, it was a turning point in understanding everything in kind of demystifying everything that I knew about data, and trying to understand the dynamics that came out of social networks. And from that time on, I started really studying not only how people behave on these social networks, the trust factor that came out of it, but also the data stories that came out of it. And the panacea for me was trying to contextualize the information that came out of these social networks and how to actually draw conclusions and marry that information with transaction. And so that evolved eventually into the AI space, which I am in now. And to be able to marry that kind of information is awesome in terms of understanding what that could mean for many services and products, but it's also a scary thing. So this is the reason why I joined Humans for AI, because I think we really need a plan to try to control it when it happens. So this is our founder. Her name is Bina Amanath, and she is out of Palo Alto, the Global VP of Data Artificial Intelligence and Innovation at Hewlett-Packard Enterprise. And I've provided this quote because it gives you an idea of the essence of who we are at Humans for AI. AI's pervasive impact will require humanity to control the pace to which it is woven into the fabric of our lives. We believe that human experience must be integral to building AI solutions. Domain expertise through human-assisted AI will become more important for better and safer AI products in the futures. Humans who want to thrive in the AI world will also need to learn and understand how they can facilitate AI within their industry and their jobs. So this is something that we believe. There is a fear factor surrounding AI and the displacement of individuals. We don't believe that that's the case. And I can talk a little bit more about that. So our mission is to demystify AI and build a society of inclusion. So what we want to do is we want to recruit women and minorities in the workplace. We want to be able to show them, demystify AI, and make it available to them in terms of basic understanding and understanding the nuances of AI, because we believe that they could be the future product managers and product designers for leveraging AI within their industry. What we want to be able to do is enable an economic and socially sustainable society in the wake of AI. And when I talk about sustainability, it means economically, we'll have a strengthened economy. We're going to create more jobs that haven't existed before. And this fear of AI in terms of displacement won't happen because there will be a renewed purpose for individual contribution. All right? Oh, okay. I'll speak into the mic. Oh my God, this sounds so much better. I am so sorry. Okay, did you hear that? Did you hear everything I said though before? Okay. Thank you. Okay, so our volunteers, we have 70 plus volunteers. We are 6 months young, And we are about 70% data scientists and engineers, spanning from Toronto, Canada, Alberta. We have people in Palo Alto, as well as India. So we are growing like crazy. We represent AI startup companies. We also represent manufacturing, banking, the service industry, et cetera. So we want to be able to bring humans for AI to the people and be able to partner with domain experts. I'll tell you a little bit more about that. So the one thing that was made pretty clear, especially in the last couple of years, is that there are three forces colliding. The rise of AI. When we talk about the rise of AI, tons of companies are coming to the forefront. There's a lot of misconceptions. There's also a lot of fear. There are people scrambling and to get more information about AI. Companies are striving to get to hire talent where there is a talent shortage. Right now, there's a lot more questions than there are answers. And so we need to fix this. Now, in technology, there's also a lack of diversity. Everybody knows this, the bro culture, right? We know that white males continue to dominate at leadership positions. Women and minorities are outpaced in terms of numbers and leadership positions, and we need to fix that. We've seen stories and heard stories from people like Ellen Pao, as well as Susan Fowler. But what has really catalyzed everything in the last 2 months has been the Me Too movement, because what it's done is it's taken the idea of gender inequality, sexual harassment to mainstream media. We saw that in publishing, we see this now in politics, we see it in sports, we see it everywhere. So what we're seeing is now a movement that is now being impacted globally, economically, politically, and socially. And that means that this is going to go unabated. And what we believe is that people will demand change. Women will demand more equality, and corporations will be tasked with trying to address these issues. Okay? I did it again, didn't I? Okay, I'm going to just talk here. So quickly, like I said, we want to broaden the pipeline for women minorities. We believe there needs to be diversity of thought, diversity of opinion, diversity of experience in building AI products. We want to create an open, exclusive community so that we can facilitate interactions with both practitioners as well as data scientists, and leverage that kind of partnership to release free products into the community. Okay? Demystifying AI means providing a basic understanding of the concepts, and we're going to target novices, high school kids, as well as non-technical people so they can understand AI. And we're going to start with education. We do have a lot of content out there in terms of blog posts, et cetera, podcasts, research, but we really want to start with creating a co-program with data scientists and domain experts. Eventually, we'll build community through conferences. We want to target that this year, and products, which will come much later. So 2018, we're tasked with actually starting the program, and we're going to target the marketing sector. There's a lot of people in marketing that understand that there are gaps that are that exist within their jobs, within their industry, whether or not be content creation, whether or not it be advertising, it could be optimization of media, et cetera. AI can work for them, and so we want to partner marketing professionals with data scientists to not only build out educational programs, but also some products as they evolve and unleash them into the marketing community. All right, so that's it for us. This gives you an idea of what we need. We need volunteers, we need writers, we need practitioners to help us evolve, and we also need donations. So if you're interested, please contact us. There's about 5 or 6 of us from Humans for AI here in the room, and if you guys could raise your hands so that they can, if you have any questions about Humans for AI, they can come to you. Okay? They're at the back room, Ali and Dave and Alyssa. Okay, thank you. So without further ado, we're going to talk about ethics for AI, what kind of society we want to have. And it's great that we have three women who are embedded in the science and the engineering of these models and these algorithms, because I'm going to task them with answering some of the questions that we, as I guess, humans, want to answer. And so we're going to cover the basic tenets of AI: privacy, bias, control, and solutions. We may not get to everything, but we'll do the best we can. All right? Okay, so let me start with, and anybody can answer if you guys want. Let's define AI to start with. Who wants to take that question? Let's define AI, and where are we today?
I can start. I don't know if it will be the definition that is the common one, but coming from an academic background, AI it's been around for a long time. So the field started sometimes in the 50s officially, and the 50s, and it's the pursuit or development of computational methods that behave in an intelligent way. So it's a really, really broad definition. It doesn't really tell you anything about how to go about it, and it doesn't really define precisely when do we decide that something is intelligent or not. And one of the founding fathers of the field said himself that as soon as it works, no one calls it AI anymore. That's a quote from the 50s, right? Now, when people talk about AI today, they typically refer to a set of algorithms that have been shown to be very successful at doing all sorts of tasks that we weren't really able to do up until 10, 5, 2 years ago, a year ago. And these algorithms are within a pretty specific domain within AI, which is called machine learning. So machine learning is specifically trying to solve this problem by using data, right? So by using algorithms that train on data, that get access to data and learn from examples, which is very different from, say, just trying to write down rules of something intelligent, which is something you could do, right? The original, chess systems and so on didn't learn from games necessarily, but human experts encoded some of the rules. And then within machine learning specifically, which is also a field that's been around for quite some time, there is the subfield of deep learning, which is a new name for pretty old methods, which are the methods around artificial neural networks. So they've been around for many years, but we never quite got them to work until quite recently. And now they're working really well. Maybe we'll get into why later. But so when people talk about these AI algorithms that are, detecting their friends in images and all of that, really they're pretty much most of the time referring to deep learning and also a bunch of methods from machine learning that are also very applicable. So that would be my take on it.
I just want to clarify a little bit, is that I think now, because AI is everywhere in the media, people usually refer to something magical. Like they say AI, and it's going to solve, and it's going to change. And every time I talk to the doctors, because I'm in a health kind of environment, they say, yes, it's magical. You will do magic for us. And this is it. I think Maher has pinpointed exactly what's going on, is that in the media, it's this kind of global artificial intelligence which will solve everything. We don't have that. What we have is machine learning, and machine learning is very good at solving specific questions. So we are getting better and better at solving very specific questions, and that's what we, the practitioners, call AI for the media. But in reality, it's machine learning.
Yeah, just to add to that, because I come more from the enterprise position. Many companies are seeing AI as the silver bullet of how they can make more money, bottom line. And why now? Because basically they've tapped out on analyzing their data with traditional BI type tools. That's not to say every company out there is, understands their data, but another reason for why now is AI is more natural, as has been pointed out, machine learning, neural nets. It seems to come under the umbrella of AI. Everybody talks about AI, the press talks about AI, it's the silver bullet. But bottom line, you need a lot of data to make it work. And so all of these companies are sitting on, especially the big ones. I personally work with a lot of the financial institutions here in Canada. They have so much data on all of us, but they have no idea how to data mine it or analyze it. So again, it presents a unique challenge to not only folks that are trying to build AI solutions, but even the academic type solutions. I have a client right now that has 1 trillion rows of data. Like that in itself is a challenging IT problem. How do you suck all that data in to be able to analyze it in an AI tool? So it's a really exciting time right now. However, as we're going to get into some of these other issues, you'd be shocked at what these companies have data on you. And in fact, every company that I work with, my first SQL query is, what do they know about Karen Bennett? And it's insightful, especially Equifax. They are tracking your cell phones, you guys, and they know if you're having an affair. So.
Okay, we're going to get into that, Karen, because that's where it becomes really creepy. So, okay, so let's start with the basis of AI, and even when we get into BI, everything starts with a model. Is that correct? Or does it start with an algorithm? I'm not sure if it's a chicken and egg thing, but can you guys explain how these models are built? Inmar, do you want to start? Anna?
Yeah,
Okay.
I mean, to me, a model, an algorithm, they kind of refer to the same thing. It's a statistical, in my case, or most of the time, is statistical / algorithmic tool that we develop or apply to an existing data. Usually, in an applied problem, the solution starts with a question. So you have to define a really good question and then figure out whether you actually have the data to address it. And then you build a model which captures the patterns in the data to map it to the question that you're interested in.
So in order to, let's just say the question, for example, the objective of trying to solve a problem, who helps you with the inputs? Is it the domain expert that actually, is it a process thing? Do we need to understand which processes go into making that decision? Let's say, for example, if you wanted to make something faster and a human had done that process over time, would you need those inputs in order to, let's say, replicate a model to make a machine do it as opposed to a human?
I think a lot of the times, it completely depends on the question that's being asked. There are all kinds of questions, including just, I have all this data, can you discover some patterns? Let me know something about it. It's called unsupervised learning. And that's very common to do kind of data exploration and data analysis. You want to do something faster? That again depends on the question, because sometimes, ultimately, once you've learned the model, it'll be faster, but to learn the model is not always that fast, so it might take a week to run. If we, choose an MCMC, it might take a year to run. And I think there's no, it's very hard to talk generally, because it really is a question. Any practitioner would really get into the bottom of what's being asked, okay, to figure out what's the right tool, what is the right machine learning direction to follow.
Okay.
Yeah, so to just add, I think your original question, AI algorithms and models, to me at least, they're pretty much the same thing. It really is, as Anna's saying, it's the question that is asked of that sort of data and the model that makes it unique. Again, just to bring an example, one of the banks that we're working with, we're trying to make it faster to do loan applications, because right now, they use Equifax or whatnot, some kind of service to say whether you're credit worthy. But is a middle ground of people that are probably credit worthy, but they might not have an Equifax score of high. So what we're doing is building some models to take in some additional data to be able to prioritize who on that middle ground of people should actually be given a loan, and quickly. The sad part, and I'm going to keep throwing these little zingers in, it will take jobs away from people, because right now that process is done by people, humans.
Okay, so let's move into the next area, because I want to start getting into this idea of privacy. And I'm going to ask you each individually within your current domains, what kind of data do you collect? And what are some of the problems that you're trying to solve? Okay, and Maher, one.
So let's start with the problem. The problem that we're trying to solve is self-driving, right? How do you get a car that can basically reason enough about the world to drive people around safely without requiring human intervention? And that's a pretty big goal. In terms of the data that is needed, so because we're using these types of algorithms that require not just a lot of data, they require label data. So Anna mentioned unsupervised learning, which is basically you give the algorithm a bunch of data and kind of try to automatically detect patterns. That is still a very difficult open problem in machine learning, how to do it properly, how to measure if you've done something useful. Supervised learning, which is another family of models and algorithms, deal with the question of, and this is the typical way people explain it. It's cats and dogs, right? So I want to build an algorithm that, given an image that I know ahead of time will either have a cat or a dog, I want the algorithm to be able to say this is a cat, this is a dog. So the way I do it in the supervised learning context is I go out and collect a lot of photos of cats and dogs. And I give them to the algorithm to process, but I also tell the algorithm for each one of these images, cat, 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 dog, dog, cat, dog, right? So I give a label for each one of these images, and then, so this is why it's called supervised, because I give a supervision signal. I tell it what's the right answer for all of these examples. Okay, and then I, crunch the machine, and something happens. And at the end of the day, now I can give the algorithm a new image, and without telling it whether a cat or a dog, I get a prediction. Right now, almost all the successful models out there are supervised models. Not all of them, but a lot of the examples that you use on a daily basis is probably supervised. And so when we collect data, we give the car the ability to see, right? So we need sensor data. We need something that perceives the environment, and this can be based on cameras. This can be based on LiDAR, which is a particular type of laser type technology. So it sends some light, it gets the light that bounces back, and it computes how far things are. You can use various types of sensors, and that gives the algorithm some insight into what's around it. But in order to do things like determine that there is a cyclist, what we do is we also label the data. So we also have actually humans say, this is a cyclist in this area of the image, and this is the road, and this is a tree, and so on. So this is the type of data that we typically collect.
Can I ask you one more question about, because we're talking about self-driving, and this is a question, and this is something that I've read, and I'm sure people have heard about it, where the self-driving vehicle has to make a decision, and it's an ethical decision about, if you were to get into an accident and it was to either save the passengers in the vehicle or to hit somebody in order to, I think my question is, which life do you choose?
Yeah, so this is a question that I've pondered on for a bit, and then it struck me that one of my answers is, which life would you choose? And I think it hints to the fact that the problem isn't really with the algorithm, right? The problem is that we haven't actually defined rigorously what is the ethical thing to do. And when people make these choices, we don't take them to court for making the wrong decision, because we don't really have a notion of the wrong decision. So an algorithm is just an algorithm. It will do what you tell it to do. So really, what this has done is brought to the surface the fact that there is these ethical considerations which humans are allowed to make fuzzy decisions about. We haven't really nailed it down, and we probably should, and then it will be a matter of legal practice, and we as engineers will implement the decisions. But it really oughtn't be the role of the engineers to decide. It ought to be society deciding, okay, now that we know that we're actually making these decisions all the time, we just don't blame anyone for making the wrong one. What should be the right one, and how should we encode it in rules, regulations, policy?
Okay, perfect. Anna?
Yeah, so I don't collect, as in I don't generate the data myself in the health area. So I work with everybody from molecular biologists who generate kind of biological data or cellular data to the doctors that are observing patients and giving me clinical data that they have collected on the patients that they have observed. So I think just to tie it back to the previous question, in my field, it's actually quite important in terms of making a decision. It is quite important to have an expert on board to be interpreting the data correctly, to be interpreting the results of the model correctly, and to know where to put the emphasis on in the model. So something that, and I learn every day. So for example, I work with a surgeon who resects thyroid cancers, and we have developed a model, and we were discussing the model to predict whether or not to do the surgery, because the surgery is very dramatic and they do too many surgeries, like 60% of surgeries are unnecessary. So we are trying to reduce that. And we said, well, we can reduce it to maybe 20%. And he said, but you are not taking into account what the patient wants. And the reality is that when they do the biopsy, for example, they don't really know whether it's cancer. They only know that it's cancer after the surgery, for sure. But if the biopsy comes back malignant, some of the patients will choose to do the surgery even if it's not strictly necessary, to be sure, to be on the safe side. So this kind of decisions will have to, from the patients, will have to come into the design of the algorithm to make sure that we give such a, an option for this information too.
What's your opinion on the collection of patient data in order to help you, let's say, aggregate the information to be able to help you in determining cures, for example?
Yeah. So I think it's absolutely necessary. I think the data, human biology, human system are very complex. There's no way that we can just guess it or just get it from a few hints. We still don't understand it very well, and by we I don't just mean the computer scientists, I mean the doctors either. And I think to create a systematic understanding of the human and to be able to predict the right treatment, we need a lot of data, which a human mind is not capable of processing themselves. So data is really key in this process, and collecting it is important to improve the kind of care that patients get.
And this is the positive side of the data collection. Once we get into the point where we're starting to collect individual data, especially when it comes to health or when it comes to personal information, that information could potentially, let's say, get to insurance companies. And when we talk about privacy, how much of it can make a decision, can contribute to a decision for that individual to get a higher premium on their insurance, because now the insurance company now knows more about them. I think that this is a question that we probably want to ask as well.
I think, so fortunately we are not in the US right now, and this is not as much of a problem, where I've heard that one of the amendments that was passed in between the tweets was to actually allow the employers to make decisions based on the DNA test, and to hire or not hire people. And I think what we definitely should not be afraid of is collecting data. We should be responsible as a society to how we use it. We shouldn't be protecting the data from the algorithms that are trying to kind of inform the doctors to make a better decision. We should be protecting the data from some, bad decision by the government. And the idea is that there are laws, and I think there are laws right now being considered in the Canadian government to say we are not allowed discrimination on the basis of your biological condition, right? And that's up to the government. I don't think we should prevent that by not collecting data. The data is being collected. It's not being used, and it's not a responsible thing to do. A responsible thing to do is to use the data to improve the treatment, and I think we can.
So Karen, I want you to talk more about, you expand on what you talked about last time from a client perspective. Maybe use a loan example. What kind of information, when we talk about Equifax, what are the kind of the data points that Equifax is currently collecting, and how they make inferences on whether or not somebody should be granted a loan?
Sure. So again, the original question is, what do we collect? So basically, anything and everything about you. So many of these large companies like Equifax, the banks, whatever, they have what they call a data warehouse of information about all the touch points that you've engaged with that brand. Equifax is sort of on the side gathering data. So they know, cell numbers, financial information. As I say, they're making assumptions based on whether your cell phone went home at night or it went to some other location on an actual activity happened. So they're starting to bring intelligence to a lot of the data that they're gathering. As well, we're working with car manufacturers like GM and Ford and whatnot, and I'm sure you're all aware that a lot of these cars talk back to the headquarters and give information. How many miles, do you need an oil change, do you need a tire change, etc. As a way for them to prompt you, you need to go into the dealer to get sort of a repair or whatnot. So again, the other with this is augmented, not just the company data, but social media. So being able to tie you to a brand and a purchase. So if you go out and talk about a product and it's in a negative way, it filters back to the brand owners so that they actually have that as part of your journey. So, you might have bought a purchase and then you complained about it on social media, and then they made a reach out to you to, maybe give you a discount, a new car, you name it. But again, what we're taking the approach is gathering that data is going on, there's no stopping it. It's been going on for years. But it's the process of how do you use that data that I think, rules and laws and whatnot have to be made, because I think everybody has heard about the Equifax mishap, where all of our data, both in the US and Canada, got taken by somebody, some set of people. So the question is what was the purpose and why? What are they doing with that data? Because every hack, into somebody's corporate systems, there is a purpose and there is some reason probably why that person is taking that data. So to me, it's creating a whole new environment of laws and sort of crime that can go on as part of stealing your data, unfortunately. But as Anna pointed out, I don't think we should stop building algorithms and understanding, because there's so much good that can come from it. Myself, for my car to say when I need an oil change, and then somebody arrives at my door, takes my car, does the service, I would pay lots of money for that feature. So hopefully I answered.
Yeah, no, you did. Okay, so let's move into bias. And Anna, can you move that slide for a sec? So I want the panel to, this one. So this is a big word. It's called recidivism. And I was doing a lot of reading about some of the models that currently exist. These are not AI models. These are models that exist within the system. And recidivism is the tendency of a convicted criminal to reoffend. Now, so as far as we know, even back in the 90s and beforehand, criminals were convicted. Criminals were convicted, and they would use psychologists to determine whether or not these people should be sentenced based on their observation of the individual. And the judge would usually look to the psychologist to determine how they would sentence that individual. In many cases, especially in the US, and this is a use case that actually happened in Texas, many of those determinations were race-based. And they basically said that the race factor, which is a person that is black, increases the incidences of crime and reoffense. So in 2002, General Corwin called, he was actually running for office, and he said he wanted to call an end to these race-based judgments. So he sought for the development of models that could determine correlations to determine the probability to reoffend, but taking out the race card. So I want to have a discussion about this because they ran huge surveys within the prison system to ask people specific questions. And I'm gonna tell you guys like what were the factors that they used, and bring up the question of causation versus correlation. Because some of the risk factors they talked about, where they were born, what was their upbringing like, their prior conviction, what part did they play in the offense for which they were arrested, was drugs or alcohol involved. The other point was how often were you stopped by the police. So remember that when people are stopped by the police, there's already an inherent bias in police judgment. Police could stop, let's say, Latinos and blacks 90% of the time. And then, let's say, 100% of the time, or maybe 85% of the time, those people are considered innocent. But by virtue of that interaction, that could be used as a factor in determining whether or not that person has the probability of reoffending. So based on this information, and these are existing models, if these models were, I guess from our perspective, deemed to have worked, we have a serious issue in perpetuating these models when AI takes over. Let's discuss this. What are your thoughts on it?
Yes, I think we have a serious problem. I think it's actually, well, it's an incredible risk, right? So in some cases, we know that an algorithm is doing a bad job, and we can kind of look at the results and analyze the results and say, oh, it's probably just catching the bias. And sometimes we can't because we don't understand the system well enough, and there's some intrinsic bias. So for example, a similar case was learned that between asthma and pneumonia. So they say that asthma is not a risk factor for pneumonia and for the risk of death, for death from pneumonia. And it's not true, but the reason the data had shown this is because people who already have asthma, they are treated so heavily as soon as they get pneumonia that they usually don't die from it. And there was already a bias in the system, which, of course, from the data was really hard to get. It had to be an expert who detected something like this. So, yes, the bias is there in the data, and sometimes we know, and sometimes we don't know. And sometimes the experts know, and sometimes they don't know. So I think we have to be really aware of it, and I think what we are starting to discuss and what we'll discuss more are not just the methods to remove the bias, but also the rules for testing the models. So how do we know, how do we test a model to identify whether there is a bias or not? What do we need to do? How do we identify this risk? But it is a huge and important problem to tackle.
So if we talk about this example specifically in Maher, and we say birth has nothing to do with it, right? We say your upbringing has nothing to do with it. The fact that there is alcohol or drugs involved, that should be a correlation right there. With respect to AI, each one of these factors is given a weight in determining how much of it is actually impacts the final decision, correct? So when we talk about fairness of AI, there's going to be a whole lot of other things that are going to come in that we may say, why are you looking at that? That means nothing. That has no bearing on whether or not that person should go to jail. How do you respond to that?
So,
as a person, not as a data scientist.
Yeah. So the models are limited in the sense that we construct them, right? We define that we, in the model you described on, the idea that you roughly touched on is that we have a bunch of factors and we assume that each one contributes some amount of weight or relevancy to a prediction, and then we somehow combine all of these weights together and out comes a decision, yes, no, or something like that. But we, as the researchers or the scientists, were the one to say, this is, I think, what's going on abstractly, that these things, we call them features in the the technical jargon, are the ones that can actually give a prediction, and that we want to, let's say, learn these weights. Or a more simplistic model would actually say, this is what, in a way, the psychologist does, right? They will say, I kind of know what this weight is, because I'm a human and I just do it automatically somehow. So the problem is in that feature, in the decision to choose these particular features and the decision on how they should be combined, and whether or not the data that you're collecting is mistakenly suggesting that there is this relations, and that has to do with the correlation versus causation, right? So maybe these are correlated, right? Probably if you come from particular socioeconomic background, there are correlations, but you have to take a step back and say, but what is really the hidden reason that is causing these correlations? Whereas people like the storytelling, they like the idea that actually one thing leads to the other, and are very quick to mix the two together. So I don't know that we have good system. People look at this question of, can we actually establish with proofs or scientific methods causation versus correlation, and it is really difficult. And usually you do it by actually being able to control the situation, so that you can remove certain factors and play around with them, which you can't do with data that you're collecting from real life type of situations. So I think the only real answer I have is that you have to constantly keep it at the back of your mind and really question what are the biases that you're injecting when you're choosing particular features, choosing a particular model. And as Anna said, we need to build these tools that allow us to really test the models and verify them in a way that could potentially expose that. But to say that we have that would be wrong.
So Karen, I'm going to ask you from an engineering perspective. What do we do? Like, systematically, is there a way to re-engineer faulty models?
So, as you've heard, I mean, there's bias in the data, and we're probably at the early stages, be it development or the data scientists, that these are problems that we need to solve. We had an example. We're now building models that identify the bias in the data, or we're starting to teach how to identify a bias in the model. When we got some banking information and it was about loans, sort of approval, what we found was it was actually biased towards your social insurance number. So if your social insurance number started with 999, you were immediately not approved for the loan. And when we dived deeper and we were talking to some of the subject experts, we found out that 999 actually is you're a new immigrant to Canada. So it was like, oh my God, is that really what we want to make our decisions on? So again, we're at, in my opinion, at early stages of trying to identify how you can figure out the bias in the data. And second of all, as has been brought up, we're very early stages in being able to before you go into production and sort of have this measure and compare type idea, how do you know that those predictions are right? Once you get out in the field and you get new data feedback coming in, you can always be comparing that your prediction actually came true. But doing it before you go live, we're not quite there.
There's something I actually want to add, which is more of like a positive point. One of the things to help the situation is to increase diversity in the teams that are working on it, because that's exactly where, if you have a woman on the team or a Latino or someone will look and say, hey, you collected images of white guys and you're building a face detector. Like, how is it going to do on women and people of various ethnicities? So having different mindsets looking at the problem and recognizing that something's missing is not it's not a scientific or a perfect way, but it helps a little or a lot.
I heard something about that, about facial recognition software that can't detect black faces. And the same thing with those hand warmers in the bathroom. You go to the bathroom and it's censored, but if you put on anything other than a white hand underneath, it won't work. So that's an example of some. Have you heard about that?
And the first seat belts killed a lot of women. Yeah, it's one of the earlier case studies. Yeah, because they were not at the right height, pressure, and so on, because you can imagine who was on the engineering team.
Yeah. So we're seeing biases everywhere, and we can even see it in let's say, we said image recognition. We also see it in voice recognition, but even in syntax and semantics, where there is an automatic bias that, let's say, men are doctors and women are teachers, right? Those kinds of things need to be looked at. And the amount of models that are already out there, and when we talk about re-engineering, how do you know? Because really AI is about trying to mimic the human brain, right? How we make decisions, how we do things. And yet we're also saying that we want AI to bring us more efficiency, more productivity, and yet the human brain is also faulty. So we kind of have to balance that out. And I think it's really good that you guys are saying that we're still early game. So I assume that we're still artificial narrow intelligence, is that right? We're not. Can you guys talk about the next stages of AI that we may be fearful of? Fearful of?
I think these are two different things. Like the bias, if you have bias in your data, you're going to have bias in the algorithm. And that reflects the biases that society has, right? Because that's where we're getting the data. And that's a thing. That's a problem right now, right here. Another aspect which is different is the notion of artificial narrow intelligence versus artificial general intelligence. So usually when people talk about the algorithms we have right now, they're narrow in the sense that, as Anna mentioned before, they solve one problem particularly well. And if you want something that solves a different problem, you need to build a different algorithm for that, and you need to go and collect specific data. So one of the things people are both excited about and concerns about is what happens when we get to this AGI, where intelligence is kind of a whole thing, and you have algorithms or robots that can go and do all sorts of things intelligently. I think we're pretty far from that, in the sense that we don't even have a roadmap inside academic research on how we get there. It's not like we know that, oh, we only need to solve these, problems, and we understand how we're going to go about solving them, and then the problem will be solved. It's just the jump from I can train an algorithm to detect faces, and I can train an algorithm to understand my voice, and I can train an algorithm to translate language, going from there to something that can do it coherently, and these algorithms are talking to each other, and they are making really robust decisions, and so on, is not something that we really have an understanding of how to pursue, at least as far as I know. And Anna, maybe,
I
or Karen.
agree. Completely agree. I think there are theoretical frameworks for thinking about AI for the last, general AI for the last 40, 50 years, but we're getting much, much better at algorithms for solving specific tasks, but the generalized AI is not quite there. OpenAI is working on some of that, but.
So let's talk about something that is a little bit more imminent. It's scary, and it's happening right now. In China, has everybody heard about the Sesame credits? The social credit scoring system out of China. They started dabbling, yes, Black Mirror. Somebody said Black Mirror. It's true. Season 3, episode 1, I think, something like that. So in China, in a large part of let's say the Middle East and developing countries, they don't have the benefit of credit scores or credit history. It's very much a cash-based society. The same holds true in China. China has been dabbling with this idea of a social credit scoring system that basically, I think that they call it a trustworthiness that allows them to aggregate data from 3 of the biggest networks there, Tencent, Baidu, Alibaba. So it's your purchasing, your social activity, and to be able to make an inference about you as an individual. But it's not only to make an inference, it's actually a mode of compliance. So let's say anything that you do that's good in social networks, that's good for the country, is considered an uptick in your social score. Anything that you do bad goes down. It could rise and fall dynamically based on your behavior and who your friends are. And so if you have a friend that just got out of jail or a friend that doesn't pay his bills, that can bode upon your social credit score. And the way they aim to do this, they say it's above board because they need some kind of credit scoring system for compliance, is that your credit score is going to be correlated based on the things that you do. So you may be allowed your application will go through if your credit score is high, or it's going to take a long time for you to, let's say, get approval for that job if you don't, if you do something bad. So this is happening right now, and I think we have the ability, based on, if we say the Tencent, Baidu's, and I forgot what the last one is, in China, Alibaba, we have the Googles, the Amazons, and the Facebooks in the Western Hemisphere. They contain a lot of the data that we have. How do you guys reconcile what's happening in China with what could be potentially true for us here?
Do you think it'll actually happen, the Sesame scores?
I think they plan to roll it out in 2020.
Yeah, so, I mean, I've read the articles. I'm not sure that over in China they're doing anything different that behind closed doors is happening here in North America. I'll bring up the Equifax and TransUnion. They are gathering a ton of data, and then they quantify, based on that data, some kind of score of you. So really, I just see it as almost the same thing. Maybe the consequences of having a lower score may be different in China. I don't know. Time will tell. I'm actually with Anna. I'm not sure it's going to come to reality. But
I think we actually have that system in a lot of different areas to different extent. For example, people have priority on airplanes, right? Based on how many miles you flew. You have priority for immigration for every country. They definitely have a scoring system, and people with higher education get better score, with multiple languages, better score, with more training,
Absolutely.
better score. So this is definitely happening. What I'm worried about is that kind of jump, that Black Mirror episode, for those of you who haven't seen, where you are at the counter and somehow you get upset and you speak a bad word, or just your heat rises and you say, oh, your score went down, so now you cannot fly the flight that you purchased. So this is compliance at a whole different level. Your behavior is being controlled by the state at every point in time.
Right.
And that's an extreme. To me, the Sesame score, the score not just for the credit system, but the score for the kind of the behavior in the society is somewhere I hope we will never get. Regardless of how much data we collect, I'm happy to collect any kind of data as long as it's not used to deny me some rights. And again, there is a legislative system that will have to be in play to make the decisions for what's okay and what's not okay, and what kind of constraints are allowed and not allowed to inflict on a person. What is the right and what is the obligation?
Right, and I think to some extent you're right. It's happening here already, whether or not we know it. We know from what I've read and what I've seen is that it increases the disparity between the rich and the poor, and by virtue of just a postal code, we know that that area has a certain level of income or wealth. And so those people, that specific factor can make people, I'd say, be denied or be targeted as a more risky person in terms of getting that loan. And so from that perspective, the poor get poorer, they get higher rates that they have to pay, and the rich don't get penalized because of these types of factors. It's happening already, but the reason I brought up the Sesame credits is because I fear that this dystopia is near, just because we have the data, and if we don't control the AI, then we could move to that point.
But just one comment. In Europe, they're setting laws this calendar year, right? To people are going to actually have to consent to you using the data, and how that's going to impact AI and all these models is going to be interesting to see how it has to get done.
So let's talk about that, because in order for us to control it, the one part of that, it's called the European General Data Protection Regulation, the GDPR. One of the things that they're allowing people to do is to consent whether or not their data could be resold. And by reselling the data, that is going to hinder AI. Do you believe that? Because you could say, this is my data. I allow it to be used in these contexts, but not here. So the data feeds alone, and the ability for an individual to say, no, you can't use that, how is that going to impact our models or our society? Maher, did you want to?
Unfortunately, it can actually have a negative effect, in the sense that if certain populations take themselves away completely from the equation, we're introducing bias. So there is like I said, irony here. If it ends up being something that is more uniformly distributed, so there aren't any specific, then you'll have less data. I think companies will find a way to incentivize people, basically. I mean, they will look at it as a problem to solve, and then you can start incentivizing people by saying, it is anonymous, we're sharing it for your own benefit to provide you with better deals, with better opportunities, and here are $10 or whatever. So maybe the solution is not going to be, maybe the problem of shortage of data is going to be alleviated, or not alleviated, solved from the perspective of the companies or whoever is trying to develop the algorithms by this. Another thing that I think is worth mentioning is I recently heard a talk by someone who is a real expert on that. So Catherine Hume from Integrate AI, who researches these policies, and she mentioned that she had spoken to a whole bunch of lawyers in Europe, and if I understood correctly her statement, and if I didn't, then that's completely on me. The legislation itself is a little bit vague, and she says the lawyers are not particularly concerned about being able to find many ways around it.
Okay, that's fair. Does anybody else have any?
Yeah,
Anna?
I think so. We experience it a lot in health because there are strict privacy laws about who can get access to what data, and if the patients were not consented beforehand, their data cannot be used for research, for example, to improve their care. So. So sometimes, if it's for better clinical practices, the patients do not have to be reconsented, but otherwise they do. And it really, the access to data, having no access to data, really impedes any progress in building these models.
Karen, do you have anything to add?
So the only thing I have to add is, as you pointed out, it's the sale. It's going to be the definition of what does it mean to sell data. Because what I'm seeing is in some of the projects we have, there's collaboration. There's no money exchanges hands, but you know, one company is sharing data with another company to get a bigger understanding about you, the humans. So I agree with, I guess, Catherine. I didn't hear her talk, but there are so many loopholes. But over time, I think what I saw the European folks trying to do was get a little bit more handle on who can use your privacy data. But at this point in time, I don't think there's any laws or anything yet that can stop it.
Okay. So this is an interesting question because we talk about the fear of displacement. What do you guys think the role of humans are in the next 10 years? Will we all be displaced in?
Yeah. So I'm going to grab this one first. Okay. You know, from all the interactions I've had with sort of enterprise, I don't see these tools replacing humans, at least in the next 10 years. I mean, my kids love Terminator, and they like to pretend that, you know, the computer is going to take over, it's going to have a human brain. What I see is humans are actually going to get smarter. I mean, we saw this with the AlphaGo. The actual players, by playing a computer, actually got smarter playing the game themselves. So I just see it as a way to augment the human. Do I think there's going to be some changes in what a job might be, like truck drivers? I'm sure Maher can talk about this. But as we get self-driving cars, do you really need a truck driver? Or, you know, there needs to be a companion to the computer in the truck, but they might not actually be driving the truck. Or, you know, even these lone sort of reviewers, they can do other tasks within the company. Doesn't mean I mean, all that means is the computer is aiding them to do their job faster.
Yeah, I think the idea is that these automation tools will do the task we don't want to do, right? Like will really automate some of the mundane, everyday, routine things that none of us enjoy at work, and so our work will actually be a lot more satisfying. I don't think there's nowhere soon the manual jobs will be replaced. That's not going to happen anytime soon. But even the jobs of the computer, I think the market of jobs, the job market will be transformed a little bit, even though I think the more realistic predictions were saying 30% of the jobs will become obsolete, and then the new jobs will show up. So I think it's so I don't have that fear, neither for me nor for my kids. I think I'm looking forward to their future being more exciting than what we have right now.
Inmar, what do you think about this? And especially, I'm not sure if this is a term that's used within your community right now about humans in the loop. Can you explain that, and whether or not you believe that that is going to be, here in the next 5 years?
So I think the term can be used in various ways, but there are different algorithmic systems that require the assistance of a person to do certain things. So for example, you need to solve a complicated task and you can automate 90% of it, but you still need someone to be part of that loop, either to monitor it or at some point take over and do something and then give the control back to the algorithm or to the machine. A lot of the way that I believe, companies like Uber will be working over the next few years is definitely with a hybrid model where kind of the automated driving is definitely supplemented by assistance from humans. And it's definitely going to be a very long process of where this model exists. And I will echo what was said before. I think that the fear of technology eliminating jobs is not a new thing and is not specific to AI. It's kind of like a repeating pattern. And the observation has always been that there are new jobs that are pretty damn hard to anticipate ahead of time. You can kind of think about, okay, what would it mean, and guess at some of the obvious things. So in the case of, say, self-driving cars, who's going to manage these fleets? Right? Who's going to go and pick up a car when it's broken? Who's going to clean them and fuel them and all of that? Even if you get the self-driving part of it, there is still so much that needs to be done around it. And there's already at least one company that's popped out, kind of anticipating that demand and are figuring out their processes. And right now it involves mostly people. But I think the more exciting cases are things we can't quite imagine. I think it will be really neat to see the new types of jobs that are created. And I think many of them are not going to be. I think people fear that, sure, there'll be a lot of jobs, but all for engineers, right? I don't think that's the case. And again, as we replace things that are more mundane, more repetitive, kind of like the calculator, right? It gives us more time to deal with the more interesting, abstract, creative, challenging, intellectually challenging aspects. And that will definitely be interesting to see.
Great. Did anybody have anything to add?
I just wanted to add that it is possible that for the new job market, people will need to get more education. So I think we have to think about how to make education more freely available for the people, and what kind of knowledge do they need to acquire will also change with time. So, but we can build on what they know, right? If my 2-year-old is already, using a computer and a phone and everything very easily, that means that some of the set of skills that I learned in high school, she will not need to learn at all because she has it essentially from birth. So I think we do have to anticipate, we do have to think about the education aspect of the humans. And I think it's very important in terms of bringing everybody into this new kind of age in the future in the market.
Yeah, I agree. And, I've been in this IT world for a lot of years now. And 2 years ago, I didn't even know what a machine learning programmer was. And so it's opening doors for new jobs. Data scientists are, almost every company out there is hiring data scientists. But, a few years ago, it wasn't sort of a career path job that I know about anyway. So I agree. It really, as jobs are transforming, it's truly the education aspect. People have to feel comfortable with technology and, and adapt. because the job that you did, 10 years ago might be changing slightly.
And I have to add that we're not, when we talk about STEM, like the new jobs don't necessarily have to be STEM related. I know there's this fear that everybody has to know math and they have to know science. But I think the new jobs that we'll create will stem out of that. And I believe Karen had talked about at one point that you need domain experts to be able to work alongside data scientists in order to make these models more effective. All right?
I will point out, you need math to get into university, though. Almost
That's
every
true.
program.
That's true.
At least currently.
All right. Okay, and I think that's a wrap. That's a wrap. So are we going to open it up to questions right now? Okay.
Yeah, so please just put your hand up if you have questions. We'll pass the mic around. Since we're recording this, we'll just give you the mic to speak into. Anybody have any burning questions?
Hi. So my question is, as people who are really aware of and exposed to some of the ways in which data is collected and how it could be used, what, if any, personal privacy protections do you put in place?
By personal privacy, do you mean protecting privacy of the customers or consumers? For myself. Oh, am I like paranoid about my data being collected?
Yeah, what data don't you share?
I'm a lot more paranoid about people than machines, personally. So I don't have a Twitter account, right? I have never liked anything on Facebook, and that's not because I fear Facebook algorithms, but I don't know what will be the social consequences of of interacting with people on such a broad basis. I don't do much because I've kind of given up on the notion of not being able to preventing Google from collecting my data. There was at some point I was thinking about it, and at some point I was like, okay, as long as I'm, not doing anything that will make me a target of a lot of attention from Google, my privacy will be de facto because I'm just one of billions of users, and I sort of trust these companies to have. I mean, when I joined Google, I had to sign like 5 different things that basically say I will never ever try to grab anyone's information specifically, not myself, not my family, not my friends, not a potential customer, not a potential hire. Like we are, so unallowed to do that it's pretty impressive. And most companies have these types of policies in place, so they actually are quite concerned about it. But of course, there could be companies who don't really care. So, so I do little things, but nothing massive. Maybe others have better.
So what I don't share is my birth date. Digitally, nobody can ask me my birth date and get a real answer. I have a fake one that I fill in all my forms with. The only people that know my real birthday is probably the government. But on the sort of flip side, yeah, I used to have personas of where I would use, a different fake name. But now that I'm in the AI world, I can see how they're cleansing the data and figuring out who you are. So I've given up. They can figure out that, Kathy Bennett is the same as Karen Bennett, is the same as, something else. So it's only my birth date now.
Yeah, I don't really hide anything.
There is
I think there's a pretty easy way to figure out Karen's birthday. Because I don't know, in the health domain, we are starting to link to the census, we are starting to link to the ministry data, we are starting to link. And the reason for that is because the point is to provide better care. And I was thinking about this a while ago, and I think I can see a lot of the benefits of sharing the information. And so far, and it might change, the stolen identity, there are lots of movies with these horror scenarios, but So far, we have not really been hurt by sharing data so much, not that I know of. Perhaps it's going to change. I think also philosophically, the notion of privacy is changing. I can see my niece, who is roughly 20 years younger than me, has a completely different notion of privacy. And her mother found out many things through her Facebook account. And it's just, these things are evolving. And I think we have to, at every point, we have to weigh the benefits that we can get from sharing some of the data versus the negatives that will come back to us.
And one more quick note on it is, as someone who understands a little bit about how these algorithms work, sometimes when I consider putting fake information, I know that I'll get, punished by having stupid ads that, are really annoying if I say that I'm a male, 50 years old, et cetera, et cetera. So I think about it now, like, nah, I don't want to get that type of spam. I'd rather get spam that is at least relevant somehow.
So I'm just going to add one other thing. So I don't know if you know, Mark Zuckerberg actually puts tape on his little video camera. So he is afraid as well. I think the other thing is I will never get a Google Home. I am so afraid of those things, Alexa, them hearing conversations. I don't know when you turn it off, it actually does go off. So listening to that information, I heard about this Mattel doll that actually listens to the child and what's going on and sends the data back to Mattel. That stuff is really scary. And so I don't think I'll ever have, is it Alexa or any of those in my home for that very. Do you?
Yeah,
and what do you think?
I think it's great. Kids don't have to ask us to play music anymore. They can just go get whatever they want off the web. It's wonderful. I think, so there were dolls in Germany, for those of you who haven't seen, there were dolls in Germany that were broadcasting information back, and there were pervs that were spying on little kids. And in Germany, they outlawed all the electronic toys in schools at least, or some kind of electronics for children's toys. I don't know the law exactly. I think this is important. This kind of things is just how far and whether it's broadcasting back and the spying on I think it may be a problem. It is possible that people are spying on me through my camera. I cannot imagine them being very excited by what they see. So it's just, yeah, I don't know. Who would care?
I have a question for you. This is more targeted towards the healthcare sector and when it comes to women. So you mentioned earlier that seatbelts used to kill women. And then we all know that the signs of a heart attack were always defined by men's health, and that generally speaking, Western medicine is always focused on men's health and symptoms and cures. I don't know, Viagra. So are you finding with big data and big data sets that we now have the ability to put the focus back on women and come up with more gender appropriate healthcare based on actual real data, real information?
So if you're asking about what's happening right now, the answer is no, because it's just so hard to change anything in healthcare. But the data is out there to make these changes. The problem is actually not just males versus females. It's just the white people have it a lot better than anybody else, and it's a problem because some of the diseases are really different depending on different factors, and we just don't have enough heterogeneity in our data to assess that properly. And I know of one case, I guess I like to be devil's advocate, I'm sorry. But I know of one case where actually the focus was on women, and that's breast cancer. So we have a lot of data on breast cancer on women, but it actually happens in male, and it happened in my family. And we had no data to go by to make any suggestions to my father-in-law. So it definitely happens both ways, and the data that we are collecting now modular the rareness of the conditions that we see. So, for example, the reason why it's not being explored in males is because it's just very rare in males. But I think it's happening, and I think it will definitely change. It's just the change in the healthcare is very, very slow.
Just a second question that's completely different, but this is for all three panelists. So developing software for a long time was controlled by engineers, and engineers design and output product that comes from very engineering perspective. And then, about 10 years ago, people got interested in design and user experience design and bringing the user to the forefront of the products. What are the implications from a design perspective for AI, with cars or healthcare, or even from a financial perspective? How do you incorporate that, and what's your kind of process?
I think you can be more data-driven. So one of the issues that I have with design is, at the end of the day, you have someone or a team that really rely on their intuitions to serve a really wide population of people. And so, there are methodologies to try and address that, personas and so on. But I still feel that it's a process that's still driven by a lot of intuition and what I think is right and what I think people would like and so on. So I actually think being able to collect data to test things in the real world. So, one of the more standard tools is A/B tests. So, you're wondering whether the button should be blue or red on your website, and instead of saying, oh, I think most people like blue better, you actually run half of your users with the blue and half with the red, and you see which works better according to some metric that you need to come up with. So these are actually nice, because often they show us that the intuitions or the hypotheses of either the engineers or the designers or the senior manager was like, oh yeah, I know best, are incorrect. And it also, automated processes allows us to explore different designs in a more systematic way. So you can, instead of, again, talking about a layout of a web page, because that's something that we did at Kobo, instead of saying, well, according to studies or 50 users we brought in and showed them something, it's better to put this little element here and that little element there. We can very systematically explore different designs, different layouts that are automatically generated, and see which one actually seems to be the best. And another thing is that you can personalize it, right? So again, traditional design, because a small number of people can do it, you're usually going to end up with a small number of designs of a certain element. Whereas if you can target it to specific people and their preferences, it gives them ultimately a better experience. So I'm kind of with the machines on this one.
So just to add to that, I mean, I used to build websites and apps, and UX and UI was really had to be tailored to almost the user that was using it. And I used to see a lot of software that got built that wasn't as usable by women, but I gotta. As I've moved into AI and machine learning, it's about the data and just asking a question. It really doesn't, most of us just want an answer to that question with some kind of, data plot or data visualization. So I really haven't seen, as we're building sort of our solutions, the need to have women versus male type solutions out there, actually. So it's interesting that you said that, because I hadn't observed it before.
Hello, thank you very much for taking the time. Very interesting talk. Every time we get to the really touchy ethics side of AI, be it privacy or the trolley problem in the case of self-driving cars, we always hear the statement that society should make these decisions, right? And you're right, engineers shouldn't be making these kind of tough ethical decisions, but how can society make this decision? Is there a meaningful debate happening right now? And if there is, how is that debate happening? Like, is there a panel of philosophy majors at Uber that's like just arguing every day and then guiding the engineers? Or are these tech companies just waiting for some sort of answer from society? And like, how can we, as members of the public, participate in this debate? Like, how do we decide? We want to decide. You know, how do you think we can do that? I know that's a tough question. I'm sorry.
There's definitely a ton of debate going on, right? Because people are coming to these types of conversations, and there is research being done on it in academic circles, and there are, government forums of different kinds. But all of that to say, I don't actually know precisely how, say, the government of Canada is planning to address these issues. I hope that they are starting by collecting a panel of experts and designing with them some sort of a solution and working towards legislation. But and I hope that this is a typical setup. But I don't really know much about government legislation and so on. And then also I hope that people are kind of advocating that this discussion should be happening and going to their representatives and saying, this is something I actually care about and I want you as my representative to go and do something about it. Not a very good answer, but that's what I've got.
So I know in healthcare, just to add to this, there are patient advocates, patient groups that are always invited to these discussions. So at least in healthcare, there's always, people try to be inclusive and to have a representation of a patient voice and things. So I know there are lots of little silos where this is being discussed. I also don't know of the exact governmental plans for how this will happen, but it is happening at the both scientific, in the scientific communities and in the more kind of administrative roles as well.
Yeah, and on the financial side, I mean, there's starts of a standard board on sort of what the models can predict, or so there's I think it's Bill 223, but it really is going to govern the banks, because all of us can go to a bank when a bank makes a decision and have to have an audit of how that decision was made. And so I know with the models that we have been building, and I'm sure all of you have heard of blockchain, there needs to be an auditable trail to how that machine made that decision. And so the government is starting to put some laws together. I don't know how you can participate, but I mean, it's in. If you look up E23, I'm sure you'll find how you might be able to participate in that movement.
Hi. First of all, I'd like to say thank you for your honest input. I really feel that you're really, all three of you are really giving your honest opinions, and I respect that. I have a question for all of you, but I'll try to make it individual. So I know for a fact that John Deere already has, for over 20 years, driverless technology. They use it in like cornfields and very large fields. And the machine drives, they have someone in the vehicle. He usually runs a computer, he or she, usually he, runs a computer. And basically it goes in straight lines back and forth on the huge, huge cornfields and stuff. And it goes back and forth, and what he is making sure is that it doesn't run off the road and like run into a next field or anything like that. So it has existed for 20 plus years. And then when we talked to you, Anna, about medicine, medicine we know has been around from the beginning of time, and collecting data. And I just think about like the plagues in England, and just sicknesses that have gone on for centuries and centuries. We've been collecting information. And I work in an enterprise. That's my day job. I write code and I work for huge Fortune 500, huge companies where we look at the data mining. So if I was to ask all three of you on the panel, what changes have you seen in the last as much, 5 to me is like old, but in the last 2 years in all of your fields. So to me, these are existing fields, but they're advancing so rapidly and so interestingly in the AI platform. What have you seen that's different that's happening, or you think will happen in the next 2 years that we could stand up and say, wow, because data has been, and driverless technology, medicine, IT has been around for very long, probably longer than everybody in this room, like as long as we've been alive, maybe our grandparents. You talked about the 50s. I know there might be some people in here that were alive in the 50s, but you know what I mean? Even if we take technology, I didn't mean to say it like that. I meant, I meant to say that even beyond the 50s, like we can go really far, far back. It may not have been in like the mainframe computer format, but it's been around. What are we seeing in the very near future or currently that's different than what we know in regards to AI in all fields?
So I think the example that you gave indicates that there are various levels of difficulty. And what traditionally we have been able to do was engineer the programs and the solutions. And by that I mean someone has to go and very carefully write a set of rules that you can write down in a programmatic way. And all the problems we are able to solve doing that, we have been hacking at for many, many years in many, many domains. And a lot of the stuff we do is completely automated. I mean, you're not going to go and sort a list by yourself, right, of billion rows. But that's because we can write a very accurate recipe for doing it precisely and accurately. What has been elusive for a long time is a particular set of tasks that humans are really good at. That's just one example, but humans are really good at, so we think are very intuitive and very easy, but it was impossible to write it down programmatically, systematically. And one of them would be, here's an image, tell me what's in an image, right? Here's a photo. This is so easy for us, right? I can tell you so many things by glancing at a photo for a second. And for years, we just couldn't write down code that would solve the problem, and it was clear that writing down this set of rules is just not gonna do it. And so that's where this whole notion of machine learning, of learning from data. So the notion here is I cannot write the rules, but I can push a lot of data through some process that will somehow discover the rules by itself. So that was the idea. The mathematics were developed, and people were, inside academic circles working on it, and they had a lot of kind of smallish successes. And then in the last 3, 5, 10 years, I don't know how you want to count it, a few things happened. So first of all, data became abundant in ways that was never available before. Computing infrastructure became abundant in a way that was never available before, especially with the availability of GPUs. So it's a particular type of, graphic card that was invented for gaming, but as it turns out is really, really useful for these algorithms. And as a result of these two things, a lot of people started playing with these algorithms and playing with programming them. And so they built a lot of infrastructure that is open source and everyone can use. So now you have, the ability to crunch the data, and very easy, relatively speaking, bar to start using these algorithms because you don't need to go and really implement them yourself. There's like libraries. You just download a piece of code. You don't need to understand the internals of the algorithm and you can run it. It used to be like, back when I was in grad school, if we wanted to use a machine learning algorithm, the easiest path would probably go to sit down and write down the code because there weren't available libraries. And now, it'll take me all of 10 seconds to find it in Python, in C++, in Go, in whatever bizarre language I want. I will find an implementation of all of the standard machine learning algorithms. So for me, that's what changed, and that's why we're seeing all of these problems that used to be very elusive kind of getting checked off one by one.
Yeah, I completely agree. So the data, the computing, and the methods, everything has improved. And we never had actually all three together. So in healthcare, yes, the data was there written on a chart. It's still, for a lot of it, is written on a chart. But at least we are starting to digitize it. And once we have digitized information on individuals, we can start, learning, training our algorithms. And I think this 3 factors because they come together now in the last few years, maybe 5 years, are what's making a difference. What's making a huge difference. So the methods, because we have better infrastructure and better computing, we are trying much more complex methods.
We call it data wrangling. Being able to clean the data is definitely become more sophisticated and automated in the last couple of years. As mentioned, the hardware is catching up so that we can consume huge amounts of data as well as run these algorithms with these GPUs. And then I would actually say, I mean, you know, from my perspective, we used to do a lot of supervised learning, but we're morphing more into you get better results, or we're seeing better results with unsupervised. So the actual, you know, machine itself, once you sort of get it trained, continues to learn in a more automated way. So we've actually, pretty much all our projects have switched to neural nets and unsupervised type learnings. So yeah, it's moving fast. And it's nice to hear, because I was with Red Hat. I was part of that open source movement, but machine learning environment, I see open source. I mean, nobody even considers using a proprietary solution. I mean, I go into these, you know, companies, and the first thing they ask me is, what open source projects do you use? I mean, it's just like, holy moly, has this world changed since I started with Red Hat? Which is nice to see, because then there's a lot more collaboration, and it moves faster.
Okay, those are all really great questions. We have to close up shop for tonight, but thank you so much, ladies. That was a fantastic discussion. Let's have a round of applause for our panel. All right, so thanks everybody for coming. We hope to see you next time, and have a great evening. Thanks.